Everyone, now we are going to start examples on center of gravity. And we know that in previous lecture we have understand about the how to find out centroid as well as center of gravity. And we know that what is centroid and what is center of gravity. So for that we must have to finding out x bar and y bar for particular element like one dimensional, two dimensional and three dimensional element. For the first dimensional element, one dimensional element, we have to finding out length. For 2D element, we have to finding out area. And for 3D, we have to finding out volume. And we have equations for that, how to finding out length, area and volume and its CG or else centroid. So, let's start with example. Find the centroid of wire capital ABCD shown in the figure. This is our one dimensional element having length AB, B to C and C to D. So, we have three parts AB, BC and CD. For that, first we have to take reference axis leftmost point of the element and bottommost point of the element. Wire is one dimensional. Therefore, length of wire is to be considered. Part 1, AB part having a length 20 centimeter, X1 10 centimeter and Y1 is 0 because it is on a reference axis. Now part 2, BC line having length 15 centimeter, X bar 20 centimeter and Y bar 7.5. Same way part CD, length 10 centimeter, X3 20 plus 5 25 and Y3 15 centimeter. So put down all the values. X bar is equal to L1 x1 plus L2 x2 plus L3 x3 upon L1 plus L2 plus L3. So after putting the value we will get X bar is equal to 16.67 centimeter. Same way Y bar L1 y1 plus L2 y2 plus L3 y3 upon L1 plus L2 plus L3. So we will get 5.83 centimeter. So center of this one dimensional element G x bar y bar is equal to 16.67 centimeter and 5.83 centimeter. Now another example. Find the CG of wire. Again it's one dimensional AB line, BC line and CD line. Dear all students, for the calculation of CG you must have to remember all the x bar and y bar for the given particular shape and you have to prepare that three tables, otherwise you can't get it. So first of all put the reference axis, AB part, BC part and CD part. So three part over here. Length of AB 20, length of BC pi r and length of CD 5 centimeter. So after length put out the x bar and y bar. So part AB L1 20 centimeter, X1 0 and Y1 10 centimeter. Part 2 BC L2 pi r, X2 10 centimeter and Y2 20 minus 2 pi upon r. That you have to remember. It is coming from that table. So we will get 13.63 centimeter. Now part 3 CD 5 centimeter, total 22.5 centimeter, X3 and Y3 20 centimeter. Clear? So put the values in our equation. X bar is equal to L1 x1 plus L2 x2 plus L3 x3 upon L1 plus L2 plus L3. So we will get X bar is equal to 7.56 centimeter. Now Y bar, L1 y1 plus L2 y2 plus L3 y3. So Y bar is equal to 727.98 upon 56.4. So Y bar is equal to 10.91. So we will get G X bar Y bar is equal to 7.56 centimeter and 12.91 centimeter. This is another most important case. Thin homogeneous wire as shown in the figure, and we have to finding out the centroid of this wire having shape just like R. So here we have three parts. First vertical line, half circle, and this is inclined line. So we have dimension of all that. Part 1, first straight line, length 200 centimeter, x1 0 as you know, y1 100 centimeter. Second arc, again pi r, x2 2 pi r, 2r upon pi, and y2 100 plus 50. Part 3, straight line, L3 is equal to root of 100 square plus 100 square. That we know, it's a Pythagoras. So length we have x3 and y3, it's a half of the, means it's a center. So x bar is equal to L1 x1 plus L2 x2 plus L3 x3 upon L1 plus L2 plus L3. So we will get x bar is equal to 24.21 mm. Now y bar, L1 y1 plus L2 y2 plus L3 y3 upon L1 plus L2 plus L3. So we will get y bar is equal to 101.57. Clear everybody? Okay, good. Example number 6 is the most important. Find the CG of the line element shown in the figure. This is our one-dimensional element. Line AB, and this is again curve. So we have angle. This is our reference line X and Y. We have angle and the inclined length. So we will get horizontal and vertical dimension of this, and we know the what is inclined curve and what is half circle. So AD is equal to 43.30 centimeter and BD is equal to 25 centimeter. Now length we have, center of this part 1 L1 50 centimeter, x1 43.30 by 2, y1 25 by 2. Part BC, it's an arc, half circle. So L1, it's a pi r or else pi d by 2. X2 43.30 plus 20, y2 25 plus 2r upon pi. So we will get all the dimensions. Now put the value x bar is equal to L1 x1 plus L2 x2. Here only two parts are there. Put the values L1 x1 L2 x2. So x bar is equal to 44.78 centimeter. Now same way y bar, L1 y1 plus L2 y2 upon L1 plus L2. We have L1 y1, L2 y2, and total length 112.823. So we will get y bar is equal to 26.54 centimeter. This is another important question. Determine the centroid of the wire band as shown in the figure. Half circle and the line. Both are 10 centimeter length. First of all, we have to put the reference axis over here, and from that reference axis, we will finding out the x1, y1, x2, y2, whatever. Part 1, semicircular wire means it's half circle, it's a pi r, x1 5 centimeter and y1 2r upon pi. Again part 2, it's a straight line, 10 centimeter, x2 10 plus 5 and y2 it's 0. So x bar is equal to L1 x1 plus L2 x2 upon L1 plus L2. So we will get 8.88 centimeter. Same way y bar L1 y1 plus L2 y2 upon L1 plus L2. So it's a 1.943 centimeter. Now this is our examples of 2D. So in that case we have to finding out the area and we have to make part in the form of rectangle or else square or else triangle or else right angle triangle, circle, half circle, like that. Because we know the centroid of that shape. We know the centroid of the shape. So it's our T section. Calculate center of gravity of T section having a flange 20 by 2 means it's a 20, it's a 2 centimeter, and the wave, this is our wave, 30 centimeter by 2 centimeter. Now we have to finding out center of this T section. So first of all we have to put down reference axis over here, leftmost point and the bottommost point. We have to finalize that this is a symmetrical about y axis. So we can directly finding out the x bar. So it is 20 by 2. So x bar is equal to 10 centimeter. Then we can calculate directly. But it's not symmetrical about x axis. So we have to finding out y bar. Just to go through this figure, this is our first part, it's a one rectangle, this is our second part, this is our again rectangular. Now the section is symmetrical about y axis, that's why x bar is equal to 10 centimeter, but y bar that we have to calculate. Part 1 A1 20 by 2 it's 40 centimeter square. The y1 is equal to 30 plus 1, so it is 31 from the bottom reference axis. Part 2 A2 30 by 2 and y2 30 by 2, it's a 15 centimeter. It's again also from the bottom of the wire. So y bar is equal to A1 y1 plus A2 y2 upon A1 plus A2. Just nominal change over here. Instead of length, here we are going to take area A. So, x bar is equal to 10 centimeter and y bar is equal to 21.40 centimeter. Clear, everybody? Another important case. This is our C section. And having dimension 10 centimeter, 2.5 centimeter. This is 2.5 centimeter, this is 10 centimeter. All the flanges and waves that are 10 by 2.5 centimeter. So first of all, we have to put down reference axis over here, leftmost point and bottommost point. But the section is symmetrical about x-axis. That's why we can directly calculate y bar. So total height of this C section, that is 10 plus 2.5 plus 2.5. So it is 15 centimeter. So y bar is equal to 7.5. Clear? But not symmetrical about y axis. So we have to finding out the x bar. So for that, this is our first part, this is second part, and this is third part. Now, part 1, A1, 10 by 2.5. All the area that is same because 10 by 2.5. So, x1 is equal to 5 centimeter, x2 2.5 by 2, and x3 10 by 2. So, we will get all the dimensions. Now, equation x bar is equal to a1 x1 plus a2 x2 upon plus a3 x3 upon a1 plus a2 plus a3. So, we will get x bar is equal to 3.75. Clear? Another case. Calculate the centroid of an angle section having ISA 90 by 60 by 6 mm. Keep longer leg vertical. So, this is our longer leg vertical. It's a 90 and it is 60 and thickness is 6. Just go through it. This is 90, this is 60 from here. So, vertical dimension, net vertical dimension is equal to 84. Just go through this. Now, the section is not symmetrical about any axis. So, we have to calculate x bar and y bar both. So, first part 1, 84.6, sorry, 84 by 6. So, 504 x1 3 centimeter and y1 6 plus 84 by 2. So, it is 48. Now, part 2, a2 60 by 6 and x2 30 and y2 3. Now, x bar is equal to a1 x1 plus a2 x2 upon a1 plus a2. a1 is equal to 504 by 3. So, we will get x bar is equal to 14.25 and y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2. So, we will get y bar is equal to 29.25. Here, it's a shape of dam, rectangle and triangle. So, here we have two parts. From the reference axis, we will get rectangle and triangle. A1 9 by 3, x1 1.5, 4.5, A2 1 half into 3 into 9, x2 3 plus 1/3 of 3, it's a 4 meter. The y2 is equal to 1/3 of 9, so it is 3. So x bar and y bar we will calculate from the equation a1 x1 plus a2 x2 upon a1 plus a2. Same way y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2. So we will get x bar is a 2.33 and y bar as a 4 meter. Find center of gravity of lamina shown in figure below. This is our one kind of shape. So we have to make part as a first. From here it's a right angle triangle, second part is a rectangle, and third part is a half circle, and this half circle must be deducted from these two parts. So first triangle, 1/2 into 200 into 100, x1 2/3 of 200, and y1 200 plus 1/3 of 100. So this is our shapes. Now part 2, it's a square, 200 by 200, x2 and y2 100. Part 3, a3 pi r square by 2, x3 200 by 2, and y3 4r upon 3 pi. So after putting the value, what happening? X bar is equal to a1 x1 plus a2 x2 minus a3 x3. So here we have to deduct third part because it is a cut from the bottom square. So here a1 plus a2 minus a3, x bar and y bar we will get from that section. Clear? Now still we have some another cases that we will discuss in the next lecture. Thank you very much.